We'll begin today by talking about the purpose of having an environmental monitoring program. We understand that it is a requirement under the GMPs to have an environmental monitoring program. But what then is the exact purpose? Why do we need this? Why is it important? Why is it a regulation? It's important to have an environmental monitoring program because it provides crucial information on the quality of the processing environment during our manufacturing. And this is whether we are manufacturing in an aseptic environment or a non-sterile environment. By performing environmental monitoring, we get crucial information. We know what is going on in the environment as we are manufacturing. It also prevents the release of potentially contaminated batches if we're not meeting specifications, because during the monitoring we are taking samples. You'll see the quality control analyst in monitoring the environment and taking samples. They may be taking in process samples of the product. They will also be taking in samples of surface samples, air samples, particulate counts, and even samples of personnel as they're coming in and out of the core or the manufactured suite. And so by doing all of this, it prevents future contamination because we can then detect adverse trends in our monitoring if there's something there that is not supposed to be found in the environment, if it is a potentially harmful bacteria that we are finding in the environment, we can detect this and prevent this from happening in the future. So we're taking that samples, and part of this environmental monitoring is monitoring for bioburden or microbial monitoring. And this is a program that is designed to demonstrate the control of viable or living microorganisms in the environment. And also, we're going to do particle counts, which are going to detect non-viable particles or non-living particles in critical areas of our manufacturing suite. Now, when we're talking about these areas, we're looking at clean rooms where there's actual product filling or drug filling going on and finishing. We're looking at areas where there's formulation and tank rooms, laminar flow hoods, biological safety cabinets, isolators, even intravenous compounding areas, and also areas in which we have sterile manufacturing. So these are all the types of areas that we're going to be performing microbial monitoring in, taking viable samples to detect living microorganisms. We're also going to be performing particle counts where we're taking non-viable samples of the particulates that are in the air. So there are several types of microbial monitoring that we can do, and we just said that the viable monitoring is for living organisms. We're testing for the detection and enumeration of different types of bacteria and also for yeast and mold. And this bacteria can be bacteria that lives in an aerobic environment, meaning an environment that is that has oxygen in that environment, so they live and breathe in the presence of oxygen. And also we're looking for anaerobic bacteria, and this is bacteria that lives in the presence of no oxygen. And this is bacteria that can get into our product in sealed containers and grow. This type of monitoring includes monitoring of our personnel as they come in and out of the room, particularly if we're in an aseptic suite. It includes air and surface samples. We're taking air samples not only for particulates, which are non-viable, but we're also taking air samples for viable microorganisms as well. And we're going to discuss as we move forward how this is done. So I just told you we take non-viable samples as well of the air, and this is done in the form of particulate counts. And we know that in our environment, in the air, everywhere that we go, not only in our manufacturing suites, but there's particulates in the air. There's particulates in the air in our manufacturing suites, whether we have an aseptic suite or a non-sterile suite, we still have particles and particulates in the air. And we want to monitor these to make sure that they are meeting specifications. We can have these in the air, but depending upon the type of manufacturing that we are doing, the type of room, the class of our room, and we'll discuss that as well, there's limits for the particulates that can be found in the air per square foot or square meter. So we use a laser particle counter, which is going to be able to detect the particles in the air at certain sizes, at certain microns, and that's what we're interested in. And this would be our non-viable monitoring. So by performing environmental monitoring, it describes the processes and activities that need to take place to characterize and monitor the quality of our environment. It is a surveillance system of the bioburden or the microbiological control of our clean rooms and of other controlled environments. It's also a process by which it provides monitoring, testing, and then we get feedback of the microbiological quality levels in the manufacturing environment. And we understand that there's going to be bioburden or microorganisms within our environments. Now, if we're manufacturing in a sterile environment, that's different. And in sterile, say, laminar flow hoods or biosafety cabinets. But we want to monitor these because there's a certain level of each that is acceptable. But we have to make sure per GMP that we're falling within those ranges and per ISO standards as well. There's lots of sources of contamination. The contamination not only comes from our personnel, it comes from the air, as we just spoke about. There's particulates in the air. Contamination in our clean rooms can come from the equipment that's being rolled in or taken in, even for the equipment that the quality control analysts are bringing in to monitor the environment. That's a source of contamination. When we're bringing in excipients and raw materials into the manufacturing area, or maintenance personnel or calibration personnel are coming in and bringing equipment, or when we're changing out equipment for manufacturing, those are all sources of contamination. Cleaning agents and cleaning materials are sources of contamination within our clean rooms. Water itself is a source of contamination. Even if we're using water for injection or purified water, we have to be monitoring the water as well to make sure that it is meeting specifications. Our compressed gases like nitrogen and compressed air are also a source of contamination. Our personnel are our largest source of contamination. Anything that we bring into this environment is a source of particulate and microbial contamination. So there's lots of other things other than this, but these are some examples of how we contaminate the environment that we're manufacturing our drug products in. This is why we have to have a sound environmental monitoring program, because we have to stay abreast of what we are bringing into the clean room. And we also have to stay abreast of our cleaning procedures and make sure that our cleaning procedures are cleaning our rooms and getting rid of the bioburden, and also for cleaning our equipment. So we need to understand that a sound monitoring program requires understanding various regulations and the specifications that are set forth by these regulations. The FDA has regulations. The Internal Standards Organization, ISO, has regulations. TDA, the Parental Drug Association, the European Union, and also the USP, the United States Pharmacopoeia. These all have regulations on environmental monitoring and have specifications. Now, typically, the ISO standards is what we are going to follow. All of these standards are very similar, and they're good references, and depending upon what we're manufacturing and what regulation we're falling under, it will depend on what the specifications are. They are, however, very similar. So when we're looking at environmental monitoring, we're looking at the 4WH1 model, so to speak. We're looking at where is the contamination, when did the contamination get into the clean room, what type of contamination is it, who brought the contamination in, or how did it enter into the clean room. So these are questions that we want to keep in mind when we are monitoring where, when, what, who, and how. Our where could be something as, you know, where is this contamination? Where did it come from? It came from the manufacturing area, or is it in a dedicated location? Where did it come from? Did it come from personnel coming into the clean room from specific locations? When is another question. We have to monitor the air and surface monitoring so that we know when this started. If we're seeing an increase in particulates in the air at a certain time of day, then we know that perhaps something is going on in the environment that is causing an increase in microbial contamination. Was it personnel monitoring when the operators entered the processing area? And this is the reason that we conduct personnel monitoring. If we find a correlation between the personnel monitoring, the bioburden that we get from the personnel, and we get a correlation with that and the bioburden that we're finding inside of the manufacturing area, then there's an indication that perhaps it's being brought in on our personnel. We also monitor contact services at the end and the beginning of a field, and that's typically how we do it. Now, we can put the monitoring on a rotational basis because we do want to catch the middle of the field as well, but we're very interested in the beginning and the end, and we're interested in the filling operations. These are the critical operations. Then we're going to monitor the entire suite, whether we're filling or mixing or whatever we're doing, but these are the critical places. Typically is the field, and we want to be sure that we capture the environment at the beginning and the end of our field. So what is the testing, the accuracy conclusion of a particular area? What type of microbial or bioburden are we seeing? What type or what are our particle counts? What do they increase to? So we're looking at the type of contamination and the increased amount of particulate contamination if we're seeing that. The who, the trained personnel. Could it be our personnel, again, that are bringing in the contamination? Is it even our quality analyst, our microbiologist? And then, of course, the how. This has to do with our procedures. How are we monitoring what's going on during our manufacturing, or of our personnel following procedure? Is our quality analyst following procedure? Are they taking samples accordingly? Are they following GMP regulations? What policies and procedures? So we have to look at all of these things when we're dealing with bioburden, with environmental monitoring. Now, we do have a lot of aseptic processing, and aseptic processing means that our environment inside of that manufacturing area is going to be sterile. So therefore, when we're dealing with aseptic processes, we have to monitor personnel when the operators enter the manufacturing suite and when they leave. And we have to make sure that product contact surfaces were monitored during and at the end of the filling operation. Sometimes we monitor at the very beginning. As they're starting up, we monitor in the middle, during the fill, and then we want to monitor at the end. The beginning, during, and end are critical. If we do not capture the environment at the very beginning, we do want to be sure that on a rotational basis, we are capturing the information during that field, because we need to know what is going on, and then we need to see the end of the operation. We monitor our personnel to make sure that typically if you have personnel that are entering into an aseptic processing area, then we have gowning procedures that the personnel have to be trained on, and they have to pass a gowning certification test, because we want to understand and be sure that they're trained to gown aseptically and they're not taking bioburden into the aseptic manufacturing suites. So we will monitor them to make sure that they pass a certification, and then we're going to monitor them every day when they go in, and we're going to monitor them when they come out. And when I say monitoring, we're taking samples of different areas on the personnel as they are in their coveralls and gowns from head to toe to enter the aseptic processing area. And we're going to talk about that as we move on in the different areas where those sampling will take place. So we have our clean rooms, and we want to understand what a clean room is. And a clean room is an environment in which you move the air by way of supply and return, and to locations to control particular airborne particulates, and of course you're controlling the temperature and humidity. So you're talking about a clean room. There are HEPA filters that are going to be filtering the air, controlling the airflow, supply and return. And you're going to have you're going to have certain, particulate levels that have to be met. And you're going to have to keep your room at a certain temperature and a certain humidity. Now, for aseptic manufacturing, those particulate levels are going to be less than they are going to be for a non-sterile manufacturing area. And depending upon the particulate levels, the clean rooms are going to be classified by class. There's ISO standards, and there's also FDA standards. The FDA classifies them as class 100 to class 100,000. ISO standards are class A, B, C, and D, and we'll cover those as we move forward in the presentation. There's also the federal standard that standard 201E, and this is the federal government's basic design and performance requirements for clean rooms. Some of the information will set maximum and minimum levels, and it basically gives recommendation on the guidelines for setting the standards of your clean room. And again, I just explained what the class is. Now, the class 2, per the FDA standard, like I said, is going to be 100 to 100,000, and it's going to define the limit or measurement that the room will perform and to get rid of particles at a 0.micron size or larger per cubic foot. And that will determine the class of your room. So how many HEPA filters are in there and how many particles they're filtering at 0.5 micron in size or larger per cubic foot. Now, the FDA standard 209E has been, it's not used as much anymore as the ISO standard. But again, these are similar. The ISO standard may be just a little bit stricter, and we're going to look at those. But they're both looking at classifying your manufacturing rooms based on the particulate 0.5 micron in size that are being detected or being filtered out per cubic meter or per cubic foot. And I just mentioned that we have HEPA filters in our rooms, and these HEPA filters are what are filtering out our air and filtering out the particles. The class of the air filters, which is going to meet a minimum performance level of 99.97% on 0.3 microns efficiency. This means that your HEPA filters are going to be 99.97% efficient or effective at filtering particles as small as 0.3 microns in size out of the air of your clean rooms. And this, of course, is only an efficiency test, so, of course, it may not show small pinholes or leaks that may be in your filters, but they're still able to filter these particles. Normally, HEPA filters are marketed at 99.99%, and then you could have an additional test performed to make sure that there are no pinholes and leaks. Regardless, you are still filtering. These HEPA filters are going to be able to filter out molecules and particles as tiny as 0.3 microns in size. When we go into monitor, we're looking at the amount of particles that are 0.5 micron in size or larger in our manufacturing areas, but you can see that HEPA filters are much more efficient than that. And, excuse me, in this slide, this is an example of a HEPA filter, what the filters look like, and how it gives you an impact, gives you a little bit of an explanation, and you can see how these HEPA filters are actually filtering, excuse me, out these particles. So when we're talking about particles, we're looking at particulate matter. And what is particulate matter? Particulate matter is, of course, contamination that is in the air, is generated within our processes when we're manufacturing. It's generated as we are moving around in our clean rooms. There's simply particulates in the air. There's particulates in all air, and even in our manufacturing rooms. And a lot of the times we do generate the particulates during our processes. And of course, this is again why we monitor the air with particulate count in our processes. We know we have a process where we're dumping bags of powdered raw materials into a tank. Obviously, that is going to generate quite a few particles, but we want to know that those HEPA filters are capable and approved and see that in everyday operation those HEPA filters are capable of removing those particles quickly from the manufacturing area. We know that they're capable of moving particles as small as 0.3 microns, so we want to make sure that they are remaining efficient. So we're looking at how quickly the room recovers and returns to normal operation. And this slide is just giving you an idea of the size of particles when we're talking about something greater than 100 microns all the way down to 2.5 microns. You can see how very small the particles are. And these are tiny microscopic particles. We're not able to see these particles with our eyes. So we need to make sure that we're monitoring particles, and we need to be sure that we're hitting critical areas on a daily basis. And our critical area for daily monitoring would be a laminar flow hood, a UV pass box, an aseptic manufacturing area, manufacturing suite, or a biosafety cabinet, an isolator. We need to be sure that we're monitoring those on a daily basis, because these are our aseptic areas. These are going to be what we call our Class 100 areas or our Class A areas as defined by ISO. We can carry out weekly monitoring of our manufacturing and our processing rooms. Again, this will depend upon the classification. If we have a Class 100 or a Class A area, we want to monitor that every day. If we have a Class 100,000, then we can monitor these rooms on a weekly basis, and we can and make sure that we're hitting those rooms, however many suites we have, on a weekly basis. For our manufacturing areas, again, the finishing areas, depending upon the class, we can do monthly monitoring, but again, that's going to depend on the class and what type of manufacturing equipment that we have. We want to be sure that we're monitoring our compressed air and our nitrogens on a quarterly basis, and we do have a way of hooking up a laser particle counter to our compressed air and our nitrogen ports and monitoring the particulates that are generated there. We want to be sure that we're doing personnel monitoring on operators on a semi-annual basis, so twice a year. And this is for operators and personnel that are not entering into aseptic suites. This is for non-sterile manufacturing. We need to have our HEPA filters or our HVAC systems and our air handling units revalidated on a yearly basis. So we need to monitor those and have them revalidated or recertified every year. We can do occasional monitoring when we have technical issues with filters or maintenance or filter changes. Then we want to be sure that if someone goes in and changes out a HEPA filter, does some type of maintenance, that we do the proper monitoring then, because any time we are breaking something down or we are doing particular types of maintenance within our clean rooms, we're generating contamination. We're bringing bioburden in, and we're generating particulate contamination. So the main areas that we monitor is the air. We monitor surfaces, we monitor personnel, and we also monitor drains. And you think, well, why do we monitor drains? Well, we have drains, and we should have drains in our manufacturing areas so that all of the, anything that we clean with, the things that we're dumping can obviously go down and out, go down the drain. This is for information only. We know that this is going to give us quite a bit of contamination, but we want to see what we are generating and what's being taken out and rinsed out of our manufacturing areas. Then we're going to monitor the air, and this is includes compressed air ports as well, the air in our rooms, in our manufacturing suites, in our clean rooms, as well as our compressed air ports. We're going to monitor those for both viable and non-viable bioburden. The non-viable is, of course, your particulate count, and the viable is going to be for any type of microorganisms. And there's three ways we can do that. We can use an SAS machine, we can use acetylene plates, or we can use an RCS machine. And all three of these contain strips with media or acetylene plates or poured plates of media, and they're pulling in a certain amount of air and capturing whatever type of microorganism or bioburden might be in the air and adhering to the acetylene plate, and we're incubating it, or to the strips from the SAS or the RCS, and we're incubating them to see what we have that grows on them. Surfaces, walls, equipment, floors to some extent. Sometimes we use, not sometimes, before I was jumping ahead of myself, to monitor these types of surfaces, we'll use swabs or Rodax. Now, swabs are always good to monitor for hard-to-get-to places. If you have a filled machine and you want to monitor that filler on the spout that is actually pushing the liquid into, say, a bottle, then the swab is very good to use because it's not a flat surface. Swabs are used for difficult locations, maybe to get down into a tank, the top of a tank or the bottom of a tank or the outlet port of a tank. Anywhere that is not a smooth, flat surface, we'll use swabs for monitoring. Rodax are typically used on walls or flat surfaces where we stick the plate on, as you see in the slide, and then pull that plate right off, and anything will adhere, any bacteria will adhere to that media that is on that plate. Personnel monitoring we also do with swabs and Rodax. We use typically Rodax on the shoulders or somewhere on the body that is easy to place that Rodax down flat. And we're going to talk about each one of these in just a moment. For our surface sampling, depending again upon the class of your area, then we have different criteria. It's going to be the same for your swabs and your Rodax. So if we're looking at a Class 100 area, remember the Class 100 is the FDA standard. This would be referred to as a Class A under the ISO standard. The specifications are going to be the same. Laminar flow, biosafety cabinets, your sterile areas. Your alert level for these would be less than or equal to 10 colony-forming units per a 55-millimeter plate. The action level would be less than or equal to 25 colony-forming units per 55-micron plate. So if you're in a sterile area and you're getting up to 10 colony-forming units, that is an alert level. In a sterile area, you want to get 0, actually. So you have established alert levels and action levels. You should have SOPs in place as to what actions to take if you reach your alert level, and then again, if you reach your action level. Once you reach an action level, there should be investigations going on. There should be identifications of these organisms, and you should have SOPs in place for that. For Class 100,000, which is going to be your non-sterile manufacturing areas, you can see the alert levels are 25 colony-forming units, and the action is 58 colony, greater than, I said less, so forgive me for that, greater than or equal to 58 colony-forming units for your Class 100. So you can see the difference. There's quite a bit of difference in a Class 100 area, a sterile area, versus your non-sterile areas. Again, there should be SOPs in place that if we're reaching the alert level, is there resampling that needs to be done? How do we handle the fact that we are in a Class 100 area, that we're reaching the alert of 10 colony-forming units or more, or that we're reaching the action of 25? When we reach our action levels, we need to have SOPs in place where we, again, identify the bioburden and we carry out investigations as to how why this level is so high, what is causing it. We're looking again at our how, where, what, why. For personnel monitoring, we have acceptance criteria as well. And when we're monitoring our personnel, we're looking at areas such as the goggles. We're monitoring shoulders, chest, forearms, and wrists. And in this picture, of course, this person is gowned to go into either it could be an aseptic area if they have the goggles on, or they're gowned to go into a non-aseptic area, a non-sterile area. Regardless, these are the areas that we're going to look at for personnel monitoring. The alert levels for typical personnel monitoring are going to be greater than or equal to 3 colony forming units or greater than or equal to 5 for your action level. We want to know, particularly for employees and personnel entering sterile manufacturing areas, that they're carrying in little to no bioburden. That is why these limits are so low. And on their fingertips, you notice that the limits go down even further to greater than or equal to 1 colony forming unit, and that action and alert level is the same. Why? Because the fingers obviously were handling product. This is closest to product contact. So you're in an aseptic environment, you need to have zero growth, if possible, or zero bioburden. So this is why, and particularly on your hands, product contact areas. So this is why the alert levels are so low. But you do not want to bring in, you want to also bring in as little or no contamination on your body as possible, and this is why the alert and action levels are so low for personnel monitoring in the aseptic environment for their uniform or their coveralls as well. For air sampling, we just said that we're doing 2 types, viable and non-viable. The viable air sampling can be done passive air sampling with our acetylene plates, and this is when we're going to pour acetylene plates with media and set these media in critical areas. Typically, we will set these media plates in their laminar flow hoods, on a fill line, in a biosafety cabinet where people are working. And yes, we set them right in the middle of the workspace where they're working and get in the way. And we have to leave them for a period of 2 to 4 hours so that they draw in enough air that any type of bioburden can come in contact with that media. The type of media is going to depend on the type of monitoring. Typically, we're going to use tryptic soy agar, which is a universal media. If we're looking particularly for yeast and mold, we'll use another type of media. I believe it's called SDA. And forgive me, I don't have it's been a while since I've used this media, but and I don't have the exact name, but it is a media that will grow yeast and mold. And we do need to carry out yeast and mold monitoring at least quarterly, depending on the type of environment that we're manufacturing or that we live in, whether it's a humid, hot environment or a very cold environment. And of course, that may be seasonal as well as to whether we're getting lots of yeast and mold growth. And this is why typically we monitor quarterly for yeast and mold. The active air sampling measures air volumetrically, and this is where we use our RCS or SAS machines. They have strips of media that you thread into a blade that is turned on, and it pulls in a particular volume of air in a particular time frame, and that air will then attach, any microbials will be attached to that media strip, and that media strip is then incubated. And we incubate these plates at 30 to 35 degrees Celsius. In this slide, I got ahead of myself. This is acetylene plates. They have already been poured and you're going to expose them again, like I said, for either 2 to 4 hours. And typically, it's difficult with acetylene plates. We do use acetylene plates in the aseptic environment quite often. We should be monitoring them, and when you're setting them in certain places, you need to try and set them in the most critical areas, under the laminar flow hoods, in the biosafety cabinets, on the fuel line, whichever area is considered to be a Class A or Class 100 area. But keep in mind, they do get knocked on the floor by the workers, the operators. It's not because they mean to, but they do get in the way, and sometimes we have to reset them and take another 2 to 4 hours. So it can be a little bit tedious, not only for the quality control analysts, but also for the operators as well. But these are essential to our sampling. For our acetylene plates in a Class 100 area or a Class A, our alert levels and action levels, as you can see, are going to be the same. Again, a sterile area. We want less than or equal to 1 colony forming unit per a 90 millimeter plate, and this is if the plate was left there for 4 hours. In a Class 100,000 area or a Class D area, the alert and action limits are higher because this is non-sterile. So you're looking at an alert level of greater than or equal to 75 colony forming units and an action level of greater than or equal to 100 colony forming units on a 90 millimeter plate. And again, these plates have been left for 4 hours. Your volumetric air sampling, again, it's for a known quantity of air, and it's per cubic meter. If you having a look at this slide, the picture on the left with the yellow is your SAS machine. The picture on the right is your RCS machine. And as you can see, both of them have blades. They're standalone pieces of equipment, and you're going to thread strips of media into the tops, the blades, and turn these machines on. And they will run for a period of 3 to 4 minutes, depending upon whatever they're calibrated for and how much air they're going to pull in. These also will be used in critical areas like your aseptic areas. The advantage of using these is that they get in the way, obviously, of the operators, but they're only there for 4 minutes or less. So it's not as long as a acetylene plate. And again, this is up to your whatever procedures you have in place for sampling as to which ones you use. I have typically seen in the aseptic area that there's a combination of both acetylene and RCS and SAS machines being used. The acceptance criteria for these, however, for an aseptic area, Class 100 or Class A, is going to be alert level of greater than or equal to 3 colony forming units per cubic meter of air that is pulled into that machine, and an action level of greater than or equal to 5 colony forming units per cubic meter of air. And remember, it's being pulled into the machine over a certain period of time. And this picture is a laminar flow or enclosed area, so it would be a sterile area that could be within a non-sterile manufacturing area. Your active air samples for your Class 100,000, you can see they go up again, greater than or equal to 100 colony forming units per cubic meter of air, and then your actual will be greater than or equal to 200. Again, you need to have SOPs in place for what happens when you reach your alert level. Do you do extra sampling? Because we want to be sure that this is not a one-time event. If you can have sampling that you sample 3 consecutive times to make sure, or 3 consecutive days, manufacturing days, to make sure that this is a true alert level. And if any time that reaches your action level, then you have SOPs in place as to what happens when you reach your action level. When action levels are reached, you should always be identifying those organisms, because you need to know what you're dealing with and how to most effectively get rid of that organism with your cleaning process. You need to do an investigation as to how it got into the environment, why it is at such levels. Is it a training issue? Is it does retraining need to be done on gowning? Is there something that's being brought into the clean rooms that is contributing to this contamination? And all of this, excuse me, needs to be per SOPs, and then it needs to be documented, and it will have to be approved by quality assurance, reviewed and approved. Your particulate air sampling, we said a few moments ago, is done with laser particle counters, and we're looking at microns of 0.5 in size. This is what your particle counter is going to monitor. This is the level that your clean rooms are based upon. There's a certain level that they have to filter out, or that is acceptable for these particles. A certain number of these particles can be in the room, depending upon the class of your room. Surface monitoring, and we're going to look at the levels in a few moments. With our surface monitoring, we spoke about that we have two types. Rodac, these are contact plates, typically used for smooth, flat surfaces. And then, of course, swabbing. The swabbing is done in hard-to-get-to places, places where you that aren't smooth necessarily, and you can't just set a plate down. The swabs are usually dipped in. Well, what you have to have is a sterile swab, and you have to have something to deneutralize or to neutralize any cleaning agents that are on those swabs. With your Rodac, they're typically 55 millimeter plates, and as you can see in this slide, you simply open the Rodac, place it on a surface. Typically that surface, that contact time is 5 seconds. Pick the Rodac plate back up, place the cover on it, and always use some type of alcohol swab to clean the area that came in contact with that media. If you do not clean the media off of that surface, then it will just attract more bioburden, and more bioburden will grow in that particular spot. And that's not, of course, what we want. For your swabbing, typically swabs, again, are going to be sterile. They're going to be dipped in a neutralizing agent, something like sodium thiosulfate, to neutralize any types of cleaners that may have been on the surfaces that may have been used to clean. And then you're going to move that swab, hold it between your thumb and your forefinger, rolling it and moving it sideways in a 2x2 or a 4x4 square, so that you're getting a good sample of that area. You see in this picture that someone is swabbing the inside of a pipe, and that's fine. That's what we're using it for. And we just want to be sure that we're rolling that swab between our thumb and forefinger, and that we're getting a very solid, good portion of that area to be able to test. Then the swabs are then put back into the sodium thiosulfate tube, their vortex, to get all of the swab off of the stick. It's poured onto a media plate like sodium thiosulfate or SDA for yeast and mold, or another type of media for anaerobic bacteria. For our personnel monitoring, we can choose depending upon your facility, depending upon the type of manufacturing, whether you want to do this quarterly or biannually. I always say that when you're starting up a clean room, you should oversample. And when I'm starting up, I would sample my manufacturing areas regardless of the fact if they're sterile. If they're non-sterile, I would sample every day in designated spots until I am able to get a trend and get enough data for a few months to see what's really going on. I get a really good picture of what is in my clean room and what is being brought in and how my cleaning procedures are working. Same thing for personnel monitoring. I would monitor on a personally to start up. If you're starting up a clean room, I would monitor personnel on a weekly basis to gather enough information to start trending. Then I would cut it back to monthly, then cut it back to quarterly once you know what you are getting. Then depending upon what you are getting, the trending that you're seeing, the types of bacteria that you're recovering, and the type of manufacturing that you're doing, you can have procedures in place for personnel monitoring to be done quarterly or biannually. That will depend on the facility. We, again, like I said, use contact plates and swabs. Contact plates can be used on places like shoulders or knees. We typically do use them for fingers, though, when the personnel will place their gloved hand fingertips down on the Rodac plate for a contact time of 5 seconds. We want to be sure that we have procedures in place and are training our personnel to, once they have come in contact with the media, that they will change gloves, put on a new glove, and re-alcohol their hands before entering into the clean room suite. We also then use swabs to check the surfaces of goggles or even safety glasses, shoulders, chest, forearms, wrist, and the upper surface of footwear. We can also do the palm of the hand with a swab as well. We also have compressed air monitoring. We said we monitor these for particulates. We also monitor them for bioburden as well. And what you're seeing, the machine on the right is called a Matson-Garvin machine, and you're going to pour a a media plate and set it on a rotation device up under that clear hood of that machine, and it's going to be hooked up to the compressed air, and it's going to blow compressed air down on that media for a certain amount of time. It can draw in as much as 1,000 liters of air, and this is a 55 millimeter plate, and you're going to then incubate that plate at 35 degrees C and see what type of bioburden you're getting. Typically, our compressed air is monitored quarterly, and also if you have nitrogen ports, you're going to do the same. You're going to monitor those quarterly for bioburden in the same manner. Our particulate counting is, again, for non-viables. It is checking simply for the particulates in the room. It's useful for detecting significant deviations in the cleanliness from qualified processing classifications. When we've had this done, we want to monitor the area. Particle counting gives us an understanding of the air quality of the particles in the air and what we're generating also during our manufacturing process. We can use particulate monitoring as a tool for qualification. We can monitor before and after operation. And when we're starting up a clean room, it's very important, and my suggestion, to monitor particulates before and after an operation and also during the operation, because you want to see what your room is at a clean, static condition. You want to know what it is in a dynamic situation when there is manufacturing going on, and then you want to know what it is at the end of the day or at the end of the campaign when the manufacturing has stopped. It gives you a good idea of the types of particles that are being generated, the recovery of the ability of the test filters to recover the air, and also just gives you good information for trending. When we're talking about environmental monitoring, we're setting up an environmental monitoring program, we need to make sure we have good data and that we have trended that data and we can detect trends. And this is going to require a lot of monitoring at first, and then you may cut back as you see necessary. But the more data you can establish and the more information you can gain when you're first setting up a clean room is going to be advantageous to you. And of course, you're using your particulate counting to identify sensitive locations where, say, where you're dumping product, or if there's an autoclave that's opening into the room, and when you open that autoclave into your clean room, it's of course going to generate a lot of steam. So you're going to generate a lot of particles, but you can also check to make sure that HEPA filter is recovering and is pulling those particles out very quickly, and see how fast that room recovers. And in the slide here, there's a picture of a laser particle counter, and there's a few different types of laser particle counters, but the type of size of micron that they're looking at is 0.5. On the screen, you're going to see a lot of different sizes of particles, but your criteria and specifications are going to be based on your 0.5 microns. So your non-viable particulate counts are derived from the minimum number of sampling locations, and there's a way to figure this out depending upon the square meters of your room, and you will use this equation as you see here. NL equals the square root of A. The A is being the area of your room, and that's going to give you particularly your number of sites. Now, again, when I am beginning an environmental monitoring program, I'm going to look at all the critical sites in my room. I'm going to look at the critical areas that may produce particles, and I'm going to monitor there. You do not necessarily have to go by a formula. It's better to over-sample than it is to undersample. So you want to look at all of your areas, and you want to sample typically in the middle of the room, in the four corners of the room, and then where there are critical operations, or operations that are generating lots of particles. And of course, if you have specified locations with particular types of activity going on, you want to sample there. Once you have gathered enough data, then you can back off and only sample these areas. You can then put your clean room on a rotational basis and sample on a rotational basis, but you want to make sure that you are getting these areas weekly. For the particulate monitoring in a class 100,000, again, this is a non-sterile. This would be a class C or D for ISO standards. The particulate acceptance criteria, when you're looking at particles of 0.5 microns in size, for ISO standards, these should not be more than 3,520,000 per cubic meter of air. And that sounds like a lot, but a 0.5 micron particle is not visible with the human eye. If you're looking at particles that are greater than 1 micron in size, we should have no more than 832,000 per cubic meter of air. And particles of 5 microns in size should be no more than 29,300 per cubic meter of air. And again, these will be shown on your screen for your particle counters, and your particle counter is capable of giving you a printout. But the one that you're looking at that classifies your room is going to be your 0.5 micron particulate size. And we know that HEPA filters can filter out particles as small as 0.3 microns. For your class 100 or your class A, your sterile areas, excuse me, particles 0.5, greater than 0.5 micron in size should not be any more than 3,520 per cubic foot. Your 1 micron, 832, and your 5 microns, 29. And again, you're able to see these because that particle counter is going to detect these, and you'll be able to see them. It gives you a printout. Your acceptance criteria is going to be based on your 0.5 micron. It's important when you're establishing your environmental monitoring program that your HVAC system is validated. and it needs to be revalidated or recertified yearly by an external party, the one that has put the HVAC system in. There's tests that they're going to do to classify and qualify the HVAC system, and they need to come back yearly and requalify that system. The parameters are going to be your temperature, your relative humidity, and your dew point. They're going to look at air velocity, the air changes, and again, depending upon the class of your room, will tell you how many air changes per minute that you're going to have. In a class 100,000, I believe it's going to be like 49 or more air changes per minute in that room. Look at your filter integrity. They're going to look at the non-viable airborne particulates, and they're also going to take viable airborne particulate samples as well. So for temperature, relative humidity, and dew point, anyone that the ones that are certifying or requalifying your HEPA filters are going to check for temperature. They're going to check relative humidity and dew point. They're going to use calibrated thermometers. For temperature, they're going to look at and have a hygrometer, and this too, all of their equipment is going to be calibrated. They're going to check the relative humidity, and then we're going to make recordings or look at readings and record the relative humidity every 2 hours for 5 readings. And they're probably going to do this for 3 consecutive days. So they're going to be in there carrying out a HEPA filter qualification for a few days, quite some time, and typically this is done when manufacturing has shut down for a few days. A lot of plants will shut down manufacturing around the 4th of July, some around Thanksgiving and Christmas. So your HVAC requalifications can be done during these times. Your acceptance criteria, your temperature for a clean room should be between 23 degrees or plus or minus 2 degrees C. So you want to keep it around between, say, 21 to 25 degrees C. But 23 plus or minus 2 is what we're looking at. The relative humidity should be within 45 plus or minus 5%. And the low relative humidity should be within 20 plus or minus 5%. The pressure differential is also something that they're going to be looking at, the pressure differential between the rooms, and they're measuring that in pascals. So the pressure differential in the area should be more than 10 pascals across each of your manufacturing rooms. And these the vendors that will come in to do your HVAC qualification know what these limits should be, and they will have the documentation, and you should have procedures in place for reviewing their documentation and making sure that it is adequate and acceptable, and your quality assurance unit should at least have a review by and a sign-off on that, just because we want to be sure that we are reviewing information coming from our vendors. In this slide is just a picture of the equipment that they use to help them qualify your HEPA filters and your HVAC systems, an anemometer, and they do filter integrity testing. This is again when they're looking for holes and pinholes in the filters if they need to be replaced, and are they meeting their efficiency. We talked about the limits. We talked about establishing alert limits and action levels. Now, alert limits are established typically for something, and this is when we're talking about non-pathogens. When your microbial count exceeds the alert limit, when you're carrying out your environmental monitoring, you need to notify quality assurance. So you need to have an SOP in place to say what's going to happen. Quality assurance should be notified because it gives them a heads up. Production is going to continue, but you also want to notify your production managers and supervisors So, and you want to have a procedure in place where you continue monitoring that site on the next day. I recommend monitor that site for 3 consecutive days because you want to establish a trend. You want to know if this is a consistent alert level that is being generated. Was it just a one-time thing? They cleaned at the end of that day, everything is good, or is it consistent? And 3 times it's going to show you that it's consistent and that there needs to be something done. You can also have in your procedures where 3 consecutive days of that alert level will qualify as an action level, and then you want to identify that bioburden that you're seeing. You want to see, again, if these are consistent, if they increase or if they decrease. And again, like I just said, identify the isolate. And you want to monitor, the key is to monitor until it goes below that alert level. If you have procedures in place where you monitor for an alert level for 3 consecutive days and it stays consistent, it goes above and goes to the action level, or it just stays consistent, then again, like I just said, that should be considered an action level, and an investigation should be carried out, and you need to have a procedure in place to monitor this. And then what do you do once you reach your action level? As long as you are only at your alert levels, manufacturing will typically continue, and the manufacturing process will typically continue. And then when you reach your action level, typically there is another procedure that is carried out. Again, these are for and you need to, and depending upon the classification of your rooms, that tells you again by the, if you have a look at the ISO standards, which is typically, they're similar to the other standards, but most people are using ISO standards, and if you look at those, that'll give you your guidelines. When you reach your action level, this is a level in which your microbial count exceeds the action limit when you're monitoring. And again, you want to notify quality assurance. Now, typically what is going to happen when you reach an action level, quality assurance may stop production and they will carry out an investigation. And I just said that. I want you to understand that when you have an alert level and that alert level has been consistent or increasing for a period of 3 days, there should be a procedure in place that qualifies that as an action level, so that then quality assurance is notified and manufacturing is stopped, and investigation can be carried out. The reason that we stop manufacturing is because we've reached a critical level of bioburden, and we do not want that bioburden in the product. It is not, if you have a terminally sterilized product, then you can perhaps justify continuing the manufacturing because your autoclaves are going to catch that, but there does have to be tests done to prove that, and typically manufacturing will be halted, products will be quarantined and tested to make sure there was no bioburden in those products. And then, of course, you're going to carry out an investigation, and then this investigation will consist of rechecking the bioburden of all products which have been manufactured within the last 2 weeks. And particularly if you're only having monitoring going on weekly in these rooms, because it's hard for you to know when this started. If you did it last week, everything was fine, but you don't know what happened from, say, Wednesday of last week to Wednesday of this week. So that's why we want to take a look at products for the last 2 weeks when we reach our action levels. And we also you may have procedures in place to sample extra samples, because you want to make sure that you are getting a good view and carrying out a very solid investigation. Now, these were establishing alert and action levels for non-pathogens. If a pathogen is found in the monitoring, definitely, immediately, of course, notify quality assurance. And once they find a pathogen, they are going to stop manufacturing. And they're going to carry out an investigation. All of the products that have been manufactured within that period of when the pathogen was detected are going to be quarantined. They're also then going to recheck for bioburden of all products that have been, again, manufactured within the last 2 weeks, and they may be drawing extra samples. Also, there's going to be cleaning and sanitizing of the manufacturing areas per your standard operating procedures. This is also going to happen when quality assurance stops manufacturing due to any type of action level being reached. They should have procedures in place to go in and clean the areas and then go back in and monitor those areas before that manufacturing starts up again. Be sure, as part of your environmental monitoring program, that when you're training your analysts and you're training your operators and you're taking samples, that your analysts and operators have been trained on good documentation practices, that they understand standard operating procedures, they understand environmental monitoring test procedures, and how to document and sign and date testing samples and also test records. Make sure that you have trained your employees on the use of equipment and maintenance and calibration logs and procedures, that they are trained to sign cleaning and sanitation data procedures. We understand that they need to be, I go into companies all the time and I begin reviewing documents, and we need to make sure that these people understand how to document using blue or black ink, initials and date. If there is an error, one line through, initial and date with a reason code if that is part of your procedure, and no scribbling, no writing over, things like that. Be sure that they understand and are trained on action alert levels, on microbial identifications, reading environmental spreadsheets, looking at different types of data, and are trained on deviation reporting. It is very important that not only quality assurance reviews test records, but manufacturing personnel review what they have written on in their records and sampling records, as well as quality control analysts, and everyone reviews and documents correctly so that everyone knows what is going on. It's not hard to understand what has happened by reading the documentation. The guidelines for environmental monitoring, as we said earlier, is the federal standards, the FDA standards. That document is FS209E, which has now been replaced by the ISO standard, ISO 14644. The federal standard was published in 1963 and revised in 1966. They then withdrew it in 2001, and it has been replaced by the ISO standard 14644. We still talk in terms of the FDA standard as far as class 100, class 100,000, but the ISO standards are A, B, C, D, and they're similar, and you can see how they correspond. As I said, class 100 is a class A in an ISO standard. The ISO standards, though, the specifications is what is typically being used, and those specifications that we have gone through in this webinar are from ISO standards, and you can look those up and find those online. This is an example of the standards. If you look at the ISO, you have the ISO classes. Well, I am sorry. The European standards are A, B, C, and D. Forgive me for that. The ISO standards are 1 through 8. I am sorry. Forgive me. That was a mistake on my part. And I'm glad that I had this in here. I would have given you false information. The federal standard is your classifications of 100 to 100,000. They even go down to 1 and 10. The European standard is A, B, C, and D, and you can see how that classifies with Class 100. The ISO standard, ISO 5, is Class 100, all the way up to ISO 8 is Class 100,000. So I apologize for that error during this webinar, but please use this slide as your guide, and it will help you with the classification of the standards, the ISO, the federal, and of course the European, but they do all correspond. And the ones that we are typically interested in pharma manufacturing and biologics is going to be your Class 100 through your Class 100,000. So starting with your ISO 5, going up to your ISO 8. For the European standard, again, your grade A all the way up to your grade C, and there is a Class D or grade D for 100,000. Sometimes that one is used as well. For your particulate counts, as you have, and this is another good slide for you to keep if you need to have these templates or these charts sent to you. I will be glad to send them over. The ISO standard 1 and 2 and 3 and 4 are typically not used for manufacturing. Pharma manufacturing, it's going to start with ISO 5, which is going to be your Class 100. And you can see that for 0.1 microns in an ISO 5 or Class 100 or a Class A, according to the European standards, that the ISO standard of a 0.1 micron for particulate counts is 100,000. For 0.2 microns, 23,700. For 0.3, 10,200. And then you see here where you get into your regulations with your 0.5, 3,520 for Class 100,000 manufacturing area, and then they a Class 100 area, and then all the way up to 3,520 for your ISO 8 or your Class 100,000 manufacturing area. But again, 0.5 microns is what your class is based on, whether it is an ISO 5, 6, 7, or 8, or a Class A, B, C, or D. In this slide, this is a list of the documents the ISO has put out, the ISO 14644, classification of your air cleanliness, your classroom testing for compliance, all the way down. These are the standards, and you may look up each one of these standards on the web and find them. And there's also booklets that you can order from ISO for these standards as well. But these are very helpful, of course, setting up your clean rooms. There's also other regulatory requirements for microbial monitoring. Your 21 CFR 211 deals with design and construction features, which are very important. Your equipment has to be a certain design. It has to be a certain materials of construction to go into your clean rooms. 211.46 for your ventilation, your air filtration, your air handling units. 211.113 for your microbial contamination, and then 211.22 gives you a list of responsibilities for the quality control unit. There's also a federal FDA guideline for sterile drug products by aseptic processing, federal FDA guide to inspection of sterile drug substance manufacturers, the European Union guide to good manufacturing practices, the annex on manufacture of sterile medicinal products. So all of these, I put these up here because they are good guidelines. They list the regulatory requirements for microbial bioburden for construction and design of your equipment in your rooms, your air handling units for your clean rooms. And these are very good documents to have a look at and look at the requirements. There's also other requirements for industrial practices, the PDA, the technical report number 13. Pharma Research and Manufacturers has a document. So in this slide, again, the ISO 14644 for clean rooms, the USP document. Again, this slide is just a reference of documents that you may have a look at for standards and different requirements for your environmental monitoring. The challenge for setting up and maintaining clean rooms is always personnel. They are the largest source of contamination in our clean rooms. We sometimes think of equipment as being the largest source, but it's not. It's our personnel. Personnel not only bring in microbial bioburden, they also bring in particulate contamination. We bring it in our clothing, on our skin. When we are standing in a manufacturing area, standing still, we are still sloughing off particulates from our skin. This is why if we're working in an aseptic area, and you can see this on the right side, everyone is gowned head to toe. There is no skin showing. And we have to make sure that we have procedures in place, proper gowning techniques, proper training for our employees to gown, proper certification techniques, certification training programs, so that we are training and monitoring our personnel in an aseptic environment to know that they are qualified to gown, and then we have to train them how to move. We have to, when you're in an aseptic environment, movement is critical. You want to make slow, intentional movements, because every time you move, you slough off particles. You want to make sure no one is reaching inside, and whether you're in a sterile or a non-sterile manufacturing suite, but that no one is opening a coverall and reaching inside. That is a source of contamination. As you can see on the left, that's the type of gowning that we might use where skin is showing in a non-sterile environment, but we are still gowned. We want to keep as much particles inside those coveralls, not sloughing them off into the environment, and also protecting the product from skin contact, because there is bioburden on our skin. So we need to make sure that we have solid training, gowning procedures for either type of manufacturing, and that we're monitoring our personnel. And this is the point of our environmental monitoring. We'll now stop for any questions that you might have.